Oh
Okay.
yeah.
Now this recording, it's gonna be saved to your computer at the end probably.
Oh, okay.
I don't know. We'll see. So it's recording now on Zoom. Okay. This is taking a bit, isn't it?
Yeah, it's all
Okay.
right.
So you understand now how each of those numbers
Yeah.
in the area will be either a number of elements to be combined into a certain number in the groups.
Yeah.
Okay. Okay. So now what I explained is kind of on about Shanchara and
Yeah.
Shanchara is that you can think of um, you start off really with the empty
Uni.
groups. And
Yeah.
what that really means is that at the beginning of everything, you have you don't have any fundamental elements. You have an empty set of elements.
Yeah. Okay.
Now, the question is, where then does the fundamental elements that compose the world come from?
Okay.
And what this array suggests is that when you have an empty element, then you can have as much potential as you want because you can
Okay.
always have negative and positive potential.
Mm-hmm.
So I can have an empty set that's composed of a -6 and a +6, right?
Yeah.
But in this case, you assume that it starts off with negative infinity and positive infinity. Um, but this array says that you're going to proceed from negative infinity, and that negative infinity is going to include the one empty set. And so what it ends up doing is reducing whatever the negative amount is by one. And it just does that. It just does it like a big explosion,
Uh-huh.
not really in time. But, and so it goes through that process of Shanchara, like, really quickly. And so
Okay.
what would happen is that you'd really start with negative infinity,
Infinity.
and then you would add it to the one empty set, and you would progressively end up having more and more possibilities until you got all the way to zero.
Okay. So would the -6 represent the first manifestation?
Right. So I'm just starting with -6 because I can't start with negative infinity.
Yeah.
And so our first manifestations we get to -6 just to show what happens at -6, but that continues. -6 plus the empty set gives you -5. -5,
Mhm.
including the empty set, gives you -4. And it goes on to zero. And then that zero plus the -1 starts giving you the positive numbers. And
Mhm.
then it goes on to the positive side. But now you're in Pratishanchara
Yeah.
because now you actually have real positive elements that can really compose something.
Okay.
So the now it turns out that any row of these numbers will work just the same. I mean,
Mhm.
so if I go up here, say to -56,
Yeah.
okay, so and then I add that -56 to the 21, it will give me the -35
Good.
for next.
Yeah.
Can you see that?
Yeah. I see that.
And so every bottom row added to the top row gives you the next number in the bottom row. And that's a consequence of just how the formula works. But I'm not really putting a formula in here. We're just showing how the array, you can just look at the array and see this process.
Yeah.
And so it always goes from negative. But you note I have to have those alternating numbers. I have
Okay.
a positive row and a negative row.
Oh, okay. Yeah. They're alternating. Yeah.
Um,
Interesting. Okay.
and it turns out by alternating, it works out perfectly the way it's supposed to. For some reason,
Uh-huh.
we're getting feedback for some reason. Are
Oh,
you
we
hearing
don't have
me?
any. Yeah. I don't know if it's the mic. Maybe I have it too close to something. Let me put the mic a little bit further away. Does that sound better, Joppa?
Yeah, that's better, I think. But in any case, on the other side, the positive side, all the numbers are positive.
Yeah.
And they still work the same way though. The one plus, like if I click on that one, you see it,
Yeah.
and I add it to the two, then I get the three that's in the next column,
Yeah.
and so forth, right?
Yeah.
And so that's so the ideal is that this array depicts this process of moving always from Shanshara to Pratishanshara. And when you get to the positive side, then you're talking about what happens. I'm gonna be able to show you what happens when you actually compose the positive elements in Pratishanchara into these groups, how that begins to give you a hint of how the actual physics works.
Okay. So this part is where the Rishan theory comes in.
Right. Now we're going to go down here in a moment. You see where I have this series of letters?
Yeah.
So I'm going to be able to show you with the series of letters representing, you know, like over here on the end, I have this 5.
Yeah.
And so I start with one empty set, and then I have 5 letters representing possible 5 elements.
Okay.
And with those 5 elements, I'm going to show how if they start combining, they're going to start creating these complex systems. And these complex systems are going to be able to show you the properties of gravity as well as the other 3 properties that are in the standard model of physics.
Oh, okay. So these are just different combinations. That's why it's called combinatorics, right? So you're doing a
Right.
BA, CA. Okay.
You just,
Out
you
of
just,
5 different elements, different ways you can combine them.
right. And as I start to explain to you how this works out, it'll be able to start showing you how it begins to look exactly like the standard model in physics.
Okay.
Okay.
Yeah.
Okay. So the basic overall principle again is that you simply have this special array, combinatoric array, that creates um, um, sets of elements in groups that have this property of proceeding from negative infinity to positive infinity by simply adding um, the bottom number to the top number and continuing all the way across.
Yeah.
Okay, so now I'm going to show you what that looks like if you take any of these columns. So we got all these columns here, and these columns have a set of numbers. So the one I pick is the one over here for 5.
Fine. Okay.
We're going to look at that that column of numbers and see what it tells us about how elements interact in a way that is predictive of the standard model in physics. Okay, so over here, so we start with k equals 0, which means the empty set. And of course, you always have one empty set. And then if we go to k equals 1 for 5 things, then we have one. Each of the groups, there's five elements in the set, and each of them is a single one. So we have A, B, C, D, E. These are
Yes, you can have
these are groups made of
5
single
different.
elements.
Yeah.
Okay.
Okay. So just 5 different ones. Yeah.
Right. Now, so this is going to be very important because what happens here is that when I start making k equal 2, which I mean combinations of these, like I make A.
Yeah.
Hold up. Oh, shoot.
Yes, you have 2 elements to make a group or a set.
Right. So A and B.
We have 5 different possibilities, and now you're going to sort them all out.
So you ask yourself the question: how many of these order 2 groups can I make? out of 5 elements. So I have 5 elements here, those 5 elements, and I want to make these groups, this next row of groups. And it turns out I can make exactly 10.
Like
I can
1
make
or 2.
10 of these. That's exactly the number I can make.
Yeah.
Now,
And that's why you generate the number 10 after the 5.
exactly. So now what I'm going to kind of show you something on Bujik, which is kind of important, is how to generate these groups in a way that will always give you a certain kind of order. So now, so pay attention. So I'm going to click on this B, right?
Yeah.
Yeah.
Okay.
So I start with the second letter, and I say I can make a group with that B and the preceding letter, BA, right?
Yeah.
And you can see down here where I have that BA.
Yeah.
I'm putting, I took and made the B bold so you can see. Now, I can only make one of those going backwards like that, going to left. I can only make, the only letter is the A, so I can only make the BA, right?
Yep.
And then I go to the C. And since I'm at the C, I can make C, A, and CB, right?
Correct. Yeah.
And that
Because it's a way to thoroughly generate all the possible sets.
right. And then I have 2 that I can generate with the C, right?
Yeah.
Cute. You see those, the 2 C's?
Yep.
And then it keeps going like that. Then I have 3 D's.
Yep.
And then I have 4 E's.
Yeah.
Right? And if you look up here, see this green up here?
Yeah.
You can see that I have 1, 2, 3, 4.
It makes the 10.
It makes the 10. And it's the same. So I just showed you how you actually mechanically generate that 1, 2, 3, 4.
Yeah.
That's how you mechanically generated it out of using the letters. Okay.
So now I have a simple, well, it's not a simple question. I think I'm starting to understand that this is actually 2 arrays set over on top of each other, sort of. Because that's what you said. It was actually 2 asymmetrical arrays.
Well, the array is asymmetrical, so you can see that. When you should look on the negative side, it looks totally different than the positive side, right?
Yeah.
That's why it's asymmetrical. Usually, an array across the 0 will look exactly the same on the other side.
Okay.
But in this case, it's asymmetrical, and that is important. That it is asymmetrical because most arrays are not asymmetrical, and so in a way, this array too, if you turn it diagonally, I'm not going to go there because that'll get kind of complicated for now.
Okay. Okay, we can continue on.
Yeah, let's continue.
Yeah, so we did the green. I saw how you generated all the 4 numbers in green.
Right. Now, here's really a real important thing.
Okay.
Now, if I take and ask myself, now I got a new set. I got a set of double elements, which is these double elements.
Not single.
Now, if I combine these double elements, and since there's 10 of them, it turns out that there's 45 possible combinations of doubles of 10 things. If I have 10 things and I want to put them in combinations of 2, I can really generate 45, right?
Okay.
I'm just going to just accept that's true.
Yeah.
But in reality, the next set up, there's not 45 of them, the 3s, there's only 10. There's only 10 unique possible combinations of 3 you can make out of those 10 combinations of 2s.
Because you have to have 3 elements as opposed to 2.
Right. And when I combine, so say for instance, this CA and CB. If I combine those, the union of a CA and a CB will give me a CAB, okay?
Yeah.
And you can see in the next row, I have a CAB right there in front.
Oh, yeah.
And so now I have to make sure that I only get 10 because there's only 10 unique. you know, there's 45 possibilities, but there's not 45 unique ways to make the groups of three.
Please.
There's
Yeah.
only 10.
Yeah. That's the
So,
difference between what there's. I remember I was studying the combinatorics, just simple tutorials. Yeah. Yeah,
and
I
so,
understand. A unique set.
so the
Yeah.
question is, how do you guarantee that you will only get out of those 45 the 10 unique that you need?
Okay.
And the way you do that is this partitioning we already did. I already partitioned that 10 into one, a group of a subset of one, a subset of two, a subset of three, and a subset of four.
Okay.
And so I'm only going to make the combinations in those subsets.
Oh, okay.
And if I do that, then I can guarantee that I will only get the unique set of three, of combinations of three that are possible.
Okay. So these are kind of shortcuts of combinatorics.
Right. So,
Simple. Short.
so it's very, very important because if I didn't have these letters, and you can say these letters in a way represent properties.
Mhm.
And so
Yeah.
I'm trying to say, how many different ways can I combine these properties into some new element that has three of each of the properties?
Okay.
So now I'm actually, if I was talking about physics, I'd be talking about quanta that I'd be putting together to generate new sets of particles. And in physics, they're always asking that question: how many possible different kind of particles can you make out of a given number of quanta? The other important thing here is that you can ask yourself, well, what happens to all those extra combinations that aren't unique?
Hmm.
Well, it turns out that it works very nicely that those, when you're talking about gravity and curved space,
Wow.
that,
Interesting.
that those extra things are the energy that curves space time.
Uh-huh.
So, so you can say that whenever you put together a group of elements, you can only form a certain amount of unique combinations, even though there may be more possible interactions that are there. All
Hmm.
the extra interactions become the energy of curved space-time.
Okay. So it's almost like creating a world, a loca, and that's the other thing necessary to create the whole reality.
Exactly. You
Because
have
you have
to,
unique elements within, but then at the same time you have the whole outside environment that's kind of sustaining it or holding it.
exactly, exactly. So those, all those extra, seemingly extraneous combinations are actually, they can't just go away. They're actually there, and they create energy. Um, And so if you look in my, and now we can look in the, if you, I can go in the video I showed you, I go through detail how you compose each one of those. I'm not going to do it
Okay. That
here.
was was it just a second video then?
It's a third video.
Third video. Okay, because you sent me two of them. I only saw one of them so far.
So,
Other,
but you look up here, you see it.
yeah,
I'm gonna click.
yeah, yeah,
There's video
yeah. So
one,
that's the one I saw.
and then
But I didn't get to
where I
see
click
that.
now, see video two,
Yeah.
and then over here, there's video
Oh
three.
yeah. Okay. I didn't notice it because I didn't get that far.
Right. So video three is all about what I'm talking about over here.
Yeah.
And
Okay.
okay, so now, so you end up by proceeding in that mechanical way I said, by starting like with the
Yeah.
B, presenting with the A, you end up getting the exact partitioning of the set that allows for only the unique elements in the next row.
Hmm.
Now I do the same thing over here because look, if I start with this CBA, now I have to make combinations of the threes that will generate the fours, right?
Yeah.
And since I have this CBA by itself,
This is one.
it can't combine with anything, so it can't make any.
Yeah.
with 0. 1 always gives you 0 combination.
Yeah.
But now I go to the next 3, the D, and you can see all of these D's. I have 3 D's. I have a DB, then I have 2 DCs.
Yeah.
So this 3 gets partitioned into a 1 DB and then gets partitioned into 2 DCs.
Yeah.
Yeah. So the DB by itself can't make a combination. So it's another 0.
Okay.
But then I got this DCA with this DCB that makes the DCBA, the 1 DCBA in the next row.
Yeah.
And if you keep on going down here, you'll see that I can only generate these 4 elements
Yeah.
if I stay within the way they're partitioned.
Yeah.
And that's a very important, and see, this is a natural phenomena. It's kind of like in Pratishanchara, and they talk about finding the balance, between when they put the fundamental factors together.
Yeah. For life, when
Right.
life is done. Yeah.
Well, this is saying the balance is found by this kind of process happening.
Mm-hmm.
Where you really have to, you always have to generate these combinations of 2, and you got to generate them, and they will always generate in a certain way that will always give you the right numbers for each successive group.
Yeah.
With the extra ones making the surrounding environment. So you end up with the systems of matter and the surrounding curved space.
Yeah.
It automatically happens if you do these combinations in exactly the way that in a way is kind of logical,
Yeah. 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 You're not using math. You can simply look at it as combinations.
Right.
This is what only unique combinations you can get.
Exactly.
Yeah.
And so basically saying that these elements are always partitioning, and when they start partitioning like this, I call those are systems. Before, you don't have systems. If you don't have this partitioning like this, then they're not systems. They're just extensions of elements. But when they have to start partitioning this way, then you get a system of elements.
And is that begin at Pratishanchara?
Yeah, now you're in Pratishanchara when these systems of elements are being generated and
Yeah.
space-time is being curved. And then you're going to start getting the possibility of, these building up the world.